Thank you, Harry. So hi, guys. This is a not yet connected Far-Flung device for Lafarge. We hope, but I thought it would be a good introduction. Things sometimes are a little bit difficult. Sometimes my wife is asking me, what are you doing? I mean, this is IT automation, and I try to explain her this way. Lafarge is a very old company, and I'm trying to move it to the 21st century in terms of automation, software, etc. And this presentation is on this subject. So first, a small presentation, because Lafarge is not very well known. It's still a big company. So we are a world leader in building materials. So world leader in cement. The annual production, 137 million tons of cement. And just to have an idea, our biggest factory produces 30,000 tons of cement every day. So if you count, we need 1,300 trucks to get just the stuff out every day. The company has been founded in 1833, which explains also on the French side that we like paper rather than IT. But we are really good at making paper. We are providing cement, concrete, and aggregate solutions, building infrastructure, even oil wells. We do special cement for oil wells. We have 1,600 production sites all over the world in 62 countries, 15 billion sales. I mean, it's a pretty good company, plenty of sustainability ambition for the future. Very important, a lot of core values. And finally, we have the biggest research laboratory for materials in the world. It's based in Lyon, where I work. In Lafarge, I'm working in the cement branch. I'm more on the business side, not on the IT side. And I don't know if you have been able to attend the presentation this morning from General Electric. In the panel, somebody highlighted the fact that today it's not anymore about technology, it's about business. It's business-driven activity. And here, I will show you something that has been developed on the business side, not on the IT side. It's not IT-driven today. So in the cement branch, we have cement factory. Very quickly, you have a quarry. Here, you put some explosive, you blast, you make a lot of rocks, then you crush it. When you mill it, you get some powder, you cook it to 1,400 degrees, which is pretty much high temperature. Then you grind it, and finally, after a kind of kitchen where you add a few products here and there, you get cement. This is our activity. Now, cement, with the volume we have, is a really local activity. You cannot transport 30,000 tons of cement on 2,000 kilometers to get some other clients. So, factories are always in the location where the clients are. And here comes the problem. We have 155 production sites all over the world. So big factory, massive investment, like one factory, it's something like 100 to 300 million euro. And we are based in, almost everywhere, maybe not in Australia, but we have some serious position in emerging world. So when you look at this 155 production sites, you will see that we have more or less 58% in emerging countries, mostly Africa, Middle East, and Asia, which means first you have some problem of networks. Accessing a factory in the middle of Africa is not as easy as accessing something that will be in a mature country where you have optical fiber all over the place and you have good and reliable connections. So what is at stake today regarding to the Lafarge cement branch? We are heavy consumer of fuels. And long time ago, it was quite easy. We had coal, so you just light up the burner, start to produce, it goes. Now, number of fuel is exploding. We have alternative fuels. We are burning the waste of entire towns. So it's from 1 to 20, the range. we have the number of raw material that we use to fabricate the cement, and our end product is increasing. Before it was like 2, 3 products, raw materials. Now we can use up to 20. The consequence is operational complexity has increased a lot. But at the same time, in terms of performance assistance, tools and systems, we progressed, but maybe not as much as we could. And the question today is, what could we do in terms of performance assistance, tools and systems to get a step change in reliability and performance? That's the biggest question. And when you have so big footprint on the earth, plenty of factories all over the place, the first thing is you will think how I could better use my own employees' workforce in order to improve reliability and performance. So here, the problem is about remote technology, what you can do remote. And so we started to work on remote technologies because today we had a drastic change in how remote technology can be used in the industry. Before, you would have to install a very special hardware equipment in all your factories in a central place. Would be very costly. Today, it's software-based. Became very easy. So first remote technology that we might use to improve our operational KPIs is troubleshooting, so inspection, remote troubleshooting. I can see what you see at the other side of the world. The second type of remote technology is assistance. I will just connect on demand, short duration. Like I have something new in my process, I will use the best guy to help the factory that is at the other part of the world. Imagine you build one factory, I don't know, in France, and then you start to build a second factory in South Africa that is a copy-paste. Who would be in the best position to help the operators in South Africa? That would be the French guys. Would be the same. But today, I know very few companies where this is possible. The third one, type of remote assistance, remote technology, is coaching. So this is a little bit more program, long duration. So you can use it for operator on-the-job training. So during 3 weeks, you will use one guy that is the top super expert of this machine that is located in a place to help another operator that is 4,000 kilometers away. And the final one is pure remote operation. This one is a little bit more strategic decision long term. So the three first remote technologies are pretty much easy today to install or to use with a fast return on investment, whereas the last one is really difficult. You have some safety aspect, legal, stakeholders, etc. So I will not speak about it. Now, the problem, and I'm coming here to the subject of the presentation, connecting Far-Flung device, is you need to connect all of this. We can say whatever we want, big data, big networks. If you do not connect at the factory floor level, you cannot do anything. So you will say, I can use a VPN, yes, but if you have 10 systems to connect, you need to set up 10 different VPNs. So when we started to look to this problem of connectivity in Lafarge, what we made is a very simple calculation. You have 150 sites. In each site, you can have 4 to 5 different SCADA systems, 4 to 15 industrial applications. So this already is interesting. We have various network topologies. We have various OS, various versions of the same softwares. We have different business owners. So in the end, what is the conclusion about this? Is each site has 10 to 40 servers, and this is a major project. I mean, if you want to do it tomorrow, following the existing footprint, the existing industrial applications that we have here and there, this is a tremendous project. Now, let's say I'm going to my boss and I will ask him, please give me 50 million to connect all of this and do what I just described. Okay, Dominique, you have your 50 millions. I think I will not have even finished that the first part of the factory that have been connected, the setup and the architecture is already outdated. So the conclusion is this type of project is a non-acceptable solution. I mean, except we put an army of IT guys, automation guys to do the job, we will never succeed. That's as simple as that. So at this point, we said, okay, what could we do? Let's change the strategy. And first, rework the solution rather than try to compensate for the deficiencies of the past. Means deficiencies is like we have excellent industrial system, quality control, quality management, APC, but they are from various generations, some of them 15 years, some of them 20 years, that were excellent at their time, but they are not discussing together. That's number one problem. And I cannot make them accessible to everywhere in the company. So we try to make an exercise of putting some criteria. I mean, what do you need? What do we need in order to reach our target? The first one is we have a very complex one intranet, meaning that we try to align things. We have some technical specification, but it's not always possible. For example, imagine when you have a joint venture, it's not the fact that you have an IT description of your network is not necessarily applicable. So if I want to reach that factory, I need to have a solution that will allow me to go to the plant one way or another one. So the conclusion is, for this one, is we need to use pass-through protocols, no local OPC. This is, let's say, a little bit outdated. The second thing is we want a long-term solution, 10 years, maybe more. I would say I should have put 20 years. And on this point, the key is use only open source communication protocols. I don't want to depend on a proprietary solution from the supplier ABC. Even protocols are excellent. I just want something where I will be able to connect any equipment, but even the supplier disappear, I can still continue to communicate with other suppliers, other equipment. The next point is, on the client side, I don't want installation of anything. That's very, very important. You saw previously that we have 38,000 employees in the cement branch. And if I try to see all the combination who could connect to somewhere, I mean, this is a nightmare. Nightmare to install a kind of internal application on all the systems and keep it updated. I don't want that. This is just too long and too complex. So the conclusion for me is very simple. We need to use corporate pre-installed apps only, like Chrome and Java. We have also Microsoft, maybe not suitable for automation. Another point is I want to have an agile deployment and the possibility to upgrade whatever I want in real time. And this one is even more tricky. So I need to find a solution that can allow remote configuration, remote programming, bidirectional data exchange, must be online and real time. Very simple. So let's give some example. I have the plant ABC that needs a kind of configuration of a corporate application. I want to be able to access it remotely and to do 100% of things remotely without using a VPN or another alternative solution. Everything in the same place, one solution for all. Let's give another idea. It's an example I'm giving quite often. Today, if we have, let's say, a research engineer that will find that if we do ABC, we'll get a saving of 1% on the energy bill. What will happen? We are going to translate this into a standard operating procedure, into manuals, into a lot of things. But the time it will go and be implemented on the field can be several years. I mean, this is the reality. You need to train the people. You need to pass the information and ask the people to do. This is just too long. But I'm born not so far away, and I like IT. Today, it should be real time. So what we are trying to do, what we tend to is, if this engineer told us, please implement the ABC and get 1% on the energy bill, I want to have the APC program modified and roll out in the next hour. This is the way it should work today in a big corporate. So this is a concept of one push button corporate wide global update. Another example, reporting or KPI. Today, imagine you need to measure, to create a new KPI at the corporate level. To create the KPI is not an issue. To describe it is not an issue. Now to connect it and to get it calculated real time, if you have 150 local sites, can take a while. I think most of the companies will not have an update of their KPI list more than once per year. But here, I would say, if we need to measure something, we need to be able to create the indicator, program it, and roll it out in the day. Today, with everything and all the connectivity we have, there is no reason we cannot do that in real time. So in fact, after all these criteria, we tried to evaluate how we could realize that dream, because this was a dream. And the conclusion is we need to start from the bottom of the factory with a bottom-up approach. What I see very often is the guys, they start from the top with a top-down approach. What is I need on the top? And I will go downwards to in my organization to see how I can do it. But very often, this project, they fail when they reach the factory floor. Because it's easy to say, I need to want this on the top, but it's very hard to connect it in the real world when you arrive in the factory floor. So we thought, okay, let's rework and think about SCADA as an application server. Actually, that was the only solution that we found that covers our needs. And in this bottom-up approach, we said, okay, let's do not discuss about what we are going to do with this solution, connectivity. Let's speak about first how it will work in the factory. So imagine tomorrow you have a local server. The first thing we are going to do is to connect it to the company. This is the place where we will start to speak about connectivity. Second thing, connect it to the plant automation. Connect it to the plant lab equipment. Get the operators connected on the platform. Get the users or the factory employees connected to that platform. And give a certain number of communication tools like SMS, speech synthesis, emails. That's it. So here you see, I have not discussed even about what I want to do with it. You see the word SCADA, but I have not explained what I want to do with it. So it's just conceptual. You start by building your local architecture, and after you start to, you will think about what to put inside. So when you look at this, in Lafarge today, we have some peripheral applications. So SCADA displays, of course. We have a downtime application. We have a LIMS connector. We have a mining application for query management. We have advanced process control. All of these are standalone. So it means, let's say again, I'm going back to my 155 sites where I need to create the connection with displays, downtime, etc., which is a hell of a job. And finally, what we said, okay, let's rework. The job to do is so intense, it's so massive, it's better just to scrap everything and recreate applications from scrap. So the idea is, instead of having a standalone application all over the place in each factory, now we are going to build everything in the same platform. So what will be the consequence of that? Here, you have already all your data coming from the plant automation. It's there somewhere. You have all your quality coming from your lab. Each application you need to work or to create will have, by default, access to all the data that is already in the platform. I mean, technically, for example, if I want to install an advanced process control in this server, I have already all the information from the previous application, tags from the automation, quality, etc. And the beauty of that is working with this architecture means that the more data I will add, I will not have a kind of segregation, or I will not have disparate access to the data. I will not have 1,000 database. I will just have more data for that factory. So looking from a corporate point of view, I just access this place and I have everything. So in other words, here, this is the foundation for big data. We are really looking at organizing the data and getting it 100% in the same place. From the corporate point of view, here I can start to do fantastic things. I can compare all my factories over the world without difficulties. Sorry. So this is a dream. It was a dream. And you would not expect a big company to say, okay, let's do it 100% and let's go in this direction like this. So we started the pilot that is focused on 19 factories. And we have installed a few servers all over the world. So we have currently 12 operating. So in North America, in Europe, in the Middle East, in Africa, Indonesia. We have some that are also coming. And here you can understand where is one of the other business need we have. This factory here has been already attacked 3 times by Boko Haram. So you can understand we don't want to send anybody there. And this is where the remote aspect will change, will be a complete game changer. We have also installed a kind of control room where we can do whatever we want in all of these factories. And the idea is to do it worldwide. By the way, this is not coming from Google Maps. This is just a printout of the main access to our global network. So, I cannot show it now, but it works this way. You just right-click on one factory, get the list of the applications that are installed in the local SCADA, and you can jump to this in minutes. So I wanted to show you an example, a business case. And this is just a very simple example about remote diagnostic. This is, let's say, a dream that comes true. And what is the topic? So we have somewhere in the Lafarge world, the business case is you have a process issue. Experts needs the real-time plant data now. And sometimes, I'm sure it might be the same thing in a lot of companies. You have super experts, but when it comes to what you give them to work and to assess what's happening in factories, they are running, they are asking emails, they are sending emails to ask for data. In the end, they don't have the right means to work. So local process manager asks for help, something goes well in the process, and the expert will access the factory. So we can take a look to how it works. And as said previously, it starts always with a browser. So we'll get a small video. I apologize if I'm not completely synced. So the expert will just connect to the factory somewhere. And after a few times, we'll get a list of the applications that are installed in that factory. So here, we have one for the HMI and one application that is monitoring of control loops, something pretty much standard that you know. So it will start a Java client, and tada, after 30 seconds, I have access to my application. So here, this is just a statistical analysis about control loops. You can just find it. And here, the expert can see that, for example, the biggest problem in the factory is the débit SNCR in French. And he has the access to his data. No installation, no long blah blah, no client to be installed on his desktop, on laptop. He has everything. He has also everything needed to make an analysis, zoom in, out. So the expert can just find the root of the problem he's looking for. So here it's just a small example. And when he has finished his work, very often he wants to have the data. Okay, get the data and save it on his desktop. So you see, this is an example where in 3 minutes, the guy will connect all over the world, make the analysis, get the data on his laptop, and then he can conclude on what is the problem. So this is exactly what we are trying to have in the future, is to have a kind of application server where you can access everything. Ideally, here you have downtime application, APC application, you will have a reporting application, trending, and also HMI. So there is no more the question of where are the data? Where is my data? Where I can find the data? Where I can extract the data to make an analysis on it? You just go on a web page and you have access to the entire factory. So in the end, you have access to the same thing than a plant operator. This is the strategy. There is no more difference between being in the plant or being somewhere, but not using a VPN. The second business case is about remote assistance. So I can see what you see. So let's imagine we have a cement factory worldwide. It's an emerging country. There is a problem, let's say, on a vertical mill, and there are some vibration. Again, the expert needs to access. But let's be realistic. The expert does not know this factory. He does not know what is the tag name. He does not know where to find exactly the information. So you cannot just give him a list of value or a list of graphs like this. He needs to understand. So we have to speak with the same language than him. So in this example, the assistance center is called, phone is insufficient to explain the issue. Expert will connect to the plant platform. And the objective is to get a diagnosis and a remedial plan. Here, this is another factory where we have gone the same strategy, but a little bit further. And the same, it starts with a browser, and we are going to connect to the factory. And here you will see, so access to the main web page. Here you will see we have 4 applications. The first one, access to all the video cameras of the factory, monitoring of control loops, the complete HMI. We have even put a bridge where you can discuss with the local operator or people working in the factory with walkie-talkies. And this is, let's say, it's supposed to be a SCADA. So in this example, I will connect to the plant HMI. We have some other security measures that I cannot disclose. And here, the same way. After 1 minute, oh, I'm connected to the factory. No install, no heavy client, nothing. I have some hotspot. But I will go and take a look to the raw mill to see what's happening. You can see on the top, I've got the alarms as I would be in a factory. I will just click on my vibration down and get the trend of vibration. And oh, let's look, there is some problem at 11 something. Yes, I can find my data, I can analyze it. I can look at the context, because if I'm a good process expert, I'm supposed to understand all of this. I don't need a very big training course in order to study this data. Now, where it starts to be interesting is I can have infinite number of applications. I can start them at the same time. So this example here, I want to see what they are doing in the factory. Let's start the clients, the video. And here, tada, I know in real time what they are doing locally. And again, this is a SCADA. I'm not using a VPN. This is application level integration. So imagine I could start 5 different more applications at the same time. All this using one communication port only. No install, nothing. So this is what we try to do, integrating to the maximum everything in the same place. So what are the benefits, the performance results of what we're doing today? In fact, we have a drastic increase of reactivity to events from weeks to minutes. Very simple. We have plenty of factories which are in countries where you need visa. So you have a catastrophic failure somewhere. You need to send somebody. If you don't have the visa, might end up in 6 weeks to wait. Now, we can just connect to the factory, study everything, get the expert, make a statement on what's happening. So plant performance can be recovered much faster. Traveling costs are reduced, which is direct savings. Industrial system architecture. Now we go from 50, 20 servers to one application server. And on this point, before somebody will ask, what about security? Because I'm sure this question will come. Now, what do you prefer? You prefer to have 20 servers with various ports and applications to monitor, or only one server with one port? It's as simple as that. So it's much simpler to control. So the cost and complexity are drastically reduced. Here, we have done the job the proper way, because somebody might say, oh, you can use virtualization to reduce the number of servers. Yes, if I do virtualization, I will get only one. I will save on energy bill, on footprint, but the complexity will still be the same. And in practice, it will be even more complex, because you add one layer and the dependency to a guy. I mean, you need a specialist of virtualization. Otherwise, you might have some issues. The last point is data is flowing all over the one very easily. So this is a competitive advantage. I mean, you start really to leverage the number of sites you have, and you really get the data centrally. The last point is most probably the biggest one, is you can have a real-time worldwide application updates without downtime and without loss of context. For me, this point is critical. Imagine that in cement manufacturing, more or less a campaign is 11 months. You start and you don't stop during 11 months. So up to now, if you would have to make any update on your SCADA or whatever, you need to wait the next end of campaign. But if you have 155 factories, and I mean, we have more than 200 kilns, I mean, you cannot find a place in the year where you can synchronize a global update. So a big issue. Now here, we are able to update whatever we want, real time, when we want. We will not even ask the factory. We just can push an update and nobody will see it. That's the beauty. So this is the fundamentals of an agile company, because you don't need to wait. You don't need to synchronize. You just have a need and you feel it. You fulfill it immediately. And in between, we have a few lessons learned. So first, SCADA, it's not anymore just a SCADA, it's an app server. I don't know who has been at the session this morning with this excellent presentation from General Electric. What they described for the future is very much aligned to what we are doing here. There was also this excellent presentation with ExxonMobil that is also describing this. So here, it's just working. It's a demonstration. The second thing is the world has changed, and the global corporate SCADA is not a dream anymore. In fact, what we do is we have integrated everything at the factory floor level, but just after doing this job, we have integrated the factory itself as an element of a global SCADA. So we have an application where you can, it's like you can navigate from the central point, going to the local factory in one application. When you go back to the corporate application, and this is seamless experience for the user. He does not need to know where he is. Sometimes he will be in a corporate server, sometimes it will be in a factory server, but in the end, what matters is data is available, like in minutes for anybody, assuming respect of certain security procedures. And the last point is, as a consequence, a total dematerialization through architecture is now possible at the application level. So for me, this is about address the cause rather than the consequence. What is the cause? Anarchy in the plant floor. If you do not solve the problem of, let's say, extension of the number of servers application, I mean, you can do whatever you want. You can put a lot of application to collect and make the data converging. You might be successful, but it will be quite difficult to maintain and update. Here, you tackle the problem at the cause. So you just cancel the historic footprint, and you replace it with something that is, by design, fully integrated. So I will finish my speech on this, address the cause rather than the consequence. And I will leave the floor to Harry, because now